All right, so I've gone through and collected a number of these quadratic equations sheets. That's really good. And what I would like to do, I'll mark them, and then maybe there's some recap stuff that we can do together. So I'll just sort of see how we went. So thank you for that. Hopefully you got your names on them. So I
don't think I have my name. You might have to give it back.
We'll see. Okay. So we are up to exercise 2E, finding a quadratic from its graph. So the way we'll start this is we're given a bunch of words and we have to try and visualize what that means. So we have, find the equation of the following quadratics in the form ax squared plus bx plus c. So that's going to be general form. The first quadratic cuts the x-axis at x is 3 and x is minus 2, and then it passes through the point x is 2 and minus 4. So let's just start with a visualization of that. So it's going to cut the x-axis at x is 3. So here's x is 3. And it's going to cut the x-axis at minus 2. So it's over here. Those are the roots of the quadratic. And it passes through the point x is 2, y is minus 4. So here x is 2 and y is minus 4. It's passing through that point. We also know that the vertex occurs exactly halfway between these. So that's going to be at x is positive half. Minus 2 plus 3 divided by 2, positive half. That's going to be our vertex. So the quadratic is going to have this kind of shape. Okay, this is what it's going to look like. And we know it's restricted to that shape because it passes through x is minus 2, x is 3, and the point x is 2, y is minus 4. So we know it has to open upwards like that. Alright, so when we're going to find the equation of this quadratic, we'll start with what we were doing last time with linear factor form. This is linear factor form because we've got two linear factors and it shows us the roots of the quadratic equation. Our roots in this example are minus 2 and positive 3, so we're going to put those into here. We're going to have x take minus 2 and x take positive 3. And so that would just simplify to x plus 2 and x take 3. So we can express it as linear factors like that. However, we always need this a value at the front, and we always need to process it to determine this value of a using a piece of information we haven't already used. Now, if you think we've used that, we use that root, and we use that root, so we have to use this other piece of information. We have when x is 2, y is minus 4. So I'll write that here. When x is 2, y is minus 4. So I'm going to put minus 4 where the y is, and we're going to put 2 where the x is. Excuse me, minus 4 equals 8. So we have 2 plus 2, and 2 take 3. Alright, so just to repeat that, we know it passes through that point. So we're putting minus 4 where the y is and 2 where the x is. Let's process that a bit. 2 plus 2 is positive 4. And 2 take 3 is minus 1. So on the right hand side we have minus 4a. We divide both sides by minus 4. And that's going to give us a is positive 1. So the equation of this quadratic then, in linear factor form, is 1 times x plus 2 times x take 3. Now remember, this 1 out the front, we don't need it there. It's already implicit when we just have it written like that. X plus 2 times x take 3. It means that a value is 1. We have one lot of this expression. And we haven't quite finished because the question says, write it in the form ax squared plus bx plus c. So that means we need to, at the moment it's factorized, we need to fully expand it. So this is going to be a good opportunity for us to recap our FOIL. We have x plus 2 times x take 3. So FOIL, that's a way we multiply two brackets together. FOIL, it means first, outside, inside, and last. So first, we multiply the first terms together. We have x times x, that will be x squared. Okay, I'm going x times x, the first term in this bracket, times the first term in this bracket. Then we multiply the outside terms together. Now that means the term that's closest to the outside of this bracket, so x, by the term that's on the outside of this bracket, minus 3. So I have x times minus 3, that's going to be minus 3x. Okay, then we have the inside terms, so these are the ones that are right next to each other, 2 times x, and then the last terms, 2 and minus 3. If I look at the last terms, that gives me minus 6. So FOIL is a skill we start to develop in year 9. So this will work out. Now we can collect those like terms. They're the same term because they have the same power of x. We have x squared minus 3x plus 2x. That's going to be minus x. And then take 6. So that's the quadratic expressed in the form ax squared plus bx plus c. And you can move from the general form to the factorized form, or from the factorized form back to the general form. Remember, both reveal different things to you. This shows us the roots, we can see them very clearly. This shows us the y-intercept. All right, can I just point out, on the very back page of your notes book, we have a big summary of everything for quadratics. And that table, where we have forms of quadratics, we're going to keep hitting that table over and over again. So we can see in the first row, we have general form, ax squared plus bx plus c. We've just done axis-intercept form, x take p times x take q. Axis-intercepts, linear factors means the same thing. And then in the third row, that's where we have the completed square form, where we have vertex form. So that will pop up in this exercise as well. Okay, let's move on to B. We have the equation of a quadratic that touches the x-axis at 3 and passes through the point x is 1, y is 8. So, whenever we're touching the x-axis at 3, and then it passes through x is 1, y is 8, passing through that point. Whenever we're touching the x-axis, that means it's going to be the minimum point. Alright, so the minimum point or the maximum point is the coordinates of the vertex. It's touching. We're not cutting. Over here we're cutting the x-axis, we're cutting it. Here we're touching it. Here we're touching the x-axis. Now there's multiple ways we can think about it, but I think let's do this one in axis-intercept form. So we know axis-intercept form is like this. X take h squared plus k. That's a quadratic in axis-intercept form. In coordinates of the vertex form, completed square form. Now the coordinates of this vertex is x is 3, y is 0. Alright, x is 3, y is 0. And it passes through the point, x is 1, y is positive 8. So we have that coordinate there as well. So if this is our vertex, right, this is the value of h, and this is the value of k. The vertex is hk, so we can put 3 where the h is, and 0 where the k is. We'll have this quadratic equation. A times x take 3 squared. Alright, now we're going to determine the value of A by using another piece of information. A is our dilation coefficient. We've used this one, we put it in here, we put it into the vertex. So we need to use this piece of information. We have when x is 1, y is 8. And so we're going to put 8 where the y is, and 1 where the x is. Process that. Alright. So what's going on here? We put in x is 1, 1 take 3 is minus 2, minus 2 squared is positive 4. So on the right hand side we have 4a, on the left hand side we have 8. We want a by itself, so we divide both sides by 4. 8 divided by 4 is 2, so we're left with the a value, a equals 2. So that means the equation of this quadratic then is y equals 2 times x take 3 squared. Alright, now from here we're still asked to write it in the form ax squared plus bx plus c. So that means we need to fully expand this out. Now one strategy you could employ is if you wanted to use FOIL, you could go like this. X take 3 squared we know means x take 3 times x take 3. However, we should be looking at this as a perfect square and applying the perfect square rule. So I'm going to write the perfect square rule right underneath it. If we have a take b squared, again this is listed on the back of our notes booklet here. This is a rule that's very common. A take b squared, a squared, take 2ab plus b squared. So like with BEDMAS, we should do any operations in brackets, then exponents, then the multiple out the front. So we're going to leave that 2 out the front for now. That's going to have to stay there for now. And let's expand this bracket by doing the exponent. So a corresponds with x. Alright, so we're going to have a squared. Alright, a squared. Take away 2 lots of a. Take away 2 lots of a times the value of b. And in this circumstance, b is 3. Now it's not negative 3 because the negative is already there. Whenever we're doing perfect square expansion, it's just the numbers, alright? It maintains this form and we're just substituting the numbers. So a squared, take 2ab plus b squared. Alright, so we've expanded that. Let's just simplify it a little bit. So I'm going to leave that 2 out the front still. Here we have 2 times x times 3. That's going to be 6x. And 3 squared, that's going to be plus 9. And now we can distribute the 2 into that bracket. So we're multiplying every term by 2. 2x squared, take 12x. Plus 18. Okay, so that's example B. Let's have a look at C. All right, clear some space. And we're going to try and sketch it so we can visualize it. So we have cuts the x-axis at 1 and has a vertex -3, -8. So, -3, -8, that's the vertex. And cuts the x-axis at +1. So that's going to be 1 there. So it has this kind of shape, right? Here's the vertex, and it's cutting through there. And we can even anticipate what this other x-intercept is. It's implicit for us. All right? Remember, if that's the vertex, it's the axis of symmetry. And so the quadratic is symmetric about that point. The distance from there to there is 4 units. So we have from -3, so that's 3 units plus 1 unit. That's 4 units. So this route is going to be 4 units that way. So from -3, 4 units to the left, takes us to -7. And from here, we can choose, right? We've got the choice. We could do axis intercept form. So we could write it like this. X take -7, x take 1. Okay, x take b, x take q. Axis intercept form. Or we can do the vertex form. X take h squared plus k. Both of these will lead us to the exact same answer. They're both the same quadratic equation expressed in different ways. All right, so axis intercept form, we just do x take p, x take q. Vertex form, we establish that's the vertex, so the value of h is -3, the value of k is -8, so x take h squared plus k. Anyone got a preference? Let's do vertex form for this one, and then we'll do axis intercepts for the next one. All right, so we're going to follow this form through. We've got x plus 3 squared, take 8. Vertex form. Now, we need to use another piece of information. We've used the vertex, which means we can either use this one or this one. Doesn't matter. Let's go with x is 1. That's a much easier number to manipulate than x is minus 7. So we'll go, when x is 1, when x is 1, what's the y value here? What's the y value here? When x is 1, y is 0. Very good. So we're going to plug in 0 where the y is, 1 where the x is, and we're solving this equation for a. Alright, now the first thing I'm going to do is move that 8 over. I'm going to plus 8 to both sides. 1 plus 3 is 4. 4 squared is 16. Divide both sides by 16. And we'll have a is positive half. Okay. So we've got the positive half, and so the equation that we've got then is like this. It's half times x plus 3 squared, take 8. Okay, that's the equation of this quadratic. Now, we're asked to find it in the form ax squared plus bx plus c. So we want to fully expand that and then collect any like terms. So this is a perfect square again. It takes this form. I might do a little bit quicker this time, unless anyone wants me to do it nice and slowly. This is the perfect square formula. Anyone want me to do it slowly, or we all got the hang of it? All right, so we'll go x squared plus 2 times x times 3 plus 3 squared. Okay, a squared plus 2ab plus b squared. The difference between this one and the previous one is the positive there. Anytime there's a positive there, that's going to go down here, isn't it? Yeah, sure. Then we have this minus 8 hanging out the side there. Okay, now in terms of bed mass, what we need to do is distribute the half. So first let's simplify that. X squared plus 6x plus 9, take away 8. We'll distribute the half. Half x squared plus 3x plus 4.5, take 8. So we've performed the perfect square, we've distributed the half, now we can collect plus 3x. Now 4.5 take away 8 is 3.5. ax squared plus bx plus c. So I think there's a number of skills that we're bringing all together here, aren't we? First, we're finding the equation of the graph, that's good, but then we're practicing our expansion and collection of like terms. So that's C. We've got one more to go. D. We've got cuts the x-axis at x is 2 and passes through the point x is 1, y is 4. So here's x is 2, here's 1, 4. And we're told we have an axis of symmetry at x is 3.5. Alright, so I'm going to draw that dotted line there for the axis of symmetry. Now, for a quadratic to have these features, it has to go like this. If that's the axis of symmetry, it means that's the x-coordinate of the vertex. And if the vertex is at 3.5, that's 1.5 units from 2 to the axis of symmetry, which means we have another 1.5 units here. So we've got from 2 to 3.5, 3.5 plus 1.5, that's going to take you to 5. So the other root there is 5. Okay, let's do the axis-intercept form. Remember, axis-intercept form, A times x take P times x take Q. We've got P corresponds with 2, and Q corresponds with 5. And now we need to put another piece of information in. Now, we can't put x is 3.5 in because we don't know that y value. We know the x value, but we don't know how far down that y value is. So we have to use this piece of information up here. We have when x is 1, y is 4. When x is 1, y is 4. Passes through that point. So we'll put 4 where the y is, and 1 where the x is. Four equals 4a. A is 1. So this is the quadratic expressed as linear factors. We have the a value as 1, and we'll expand this using FOIL. Alright, x squared, x times x times minus 5, minus 2 times x, and minus 2 times minus 5. Now, we can even check our answers, alright, and encourage you to use your calculator to support you. You can graph this quadratic on your calculator and confirm that it has the same features that we're told. You can graph this quadratic and confirm that your expansion is correct. Alright, so your calculator's your buddy, you've got to use it to help you out. Alright, that's enough to rip into 2E. So today, just stock standard working on exercise 2E, question 1 through to 6.